Hi everyone, in this video I am going to talk about the graphics module. Now if you want to follow along with what I'm going to do in this video, you should go to the class website and you should make sure and download space.py. In particular, go to the schedule page and find that spot and click on that to download it. And after you've downloaded it, you should make sure that it's in a directory that also has graphics.py. In order for that space.py to work, you're going to need graphics.py. So download it, get it in the same directory, and open up space.py. And if you see in the code, there's a few functions. So one function that's already written is the drawStars function. And actually, so this function is responsible, as it indicates, for drawing stars. But let me show you main, or at least part of main. So main, we create a graphics canvas, have a color string in there. And we have our while true for a draw loop. So there's clear, there's update frame, and then I draw a black rectangle for the background. And then I call the drawStars function and the drawTieFighter function. So the drawStars function is already implemented with some stars, and the drawTieFighter function is something we need to implement. So the goal is going to be to add a TIE fighter to the screen that also moves when the mouse moves. So make sure you have that up and running and that it displays that canvas. Now, the next step is going to be to get a TIE fighter drawing in the center of the screen. So you should try to do this with 5 total shapes. So you can use a shape for each of the wings on the side, the line that goes across the middle, and then for the inside, you're actually going to want to use 2 circles, an outer yellow circle and then an inner blue circle, so 5 total shapes. So how would we get that to line up? Well, take the file and try to add a few lines to the drawTieFighter function to get this to display. So there's more than one way to do this, but one way is the following. So we could draw 3 lines and 2 ellipses, and we could figure out what all of those coordinates are to get it lined up in the center of the screen, put those coordinates in there, get the correct colors, and then draw the shape. So let me bring these lines of code into this function here, and we can try running it. So it does indeed get the TIE fighter over onto the screen. Now, one thing I should point out is if you are ever working on a program with the graphics module, and you have many things that you need to draw, you might not want to stick everything between the GUI.clear and the GUI.frame. You probably don't want to do that, especially because you don't want to have your functions go beyond 30 lines for the purposes of 110. So what you can do if you run into that issue is create some other functions that have GUI as a parameter, and then you can pass in your graphics object here as an argument. So that way you can kind of offload some of the drawing into another function. And then, for example, up in that drawTieFighter function, we can just say GUI.line or GUI.ellipse and do some of the drawing in other functions. So keep that design pattern in mind if you're writing programs where you want to do a bunch of drawing. But anyway, so that function, if we just want the TIE fighter to be static in the page, works all right. But what if I suddenly changed my mind and said, well, what if I want the TIE fighter to be higher up on the screen? A problem with that is if I just wanted it to be higher up, I'd have to go and potentially change a bunch of the y coordinates in this code. And that would kind of stink, right? I don't want to have to recalculate all the y coordinates. Or what if I wanted it to shift up to this corner? Then I'd have to potentially change both y and x coordinates and do that recalculation. So another way that we could write that code is doing something this way, where what we do is we create an x and a y variable to indicate this is where the center of our TIE fighter should be, and then we make the other shapes, in some cases, relative to it, or in the case of the ellipse, we actually use the x and y as the center points. So if we write it this way instead, and you have to be able to, well, in this case, I've done it for you, right? But if you do something along these lines in the future, you're going to want to make sure you have your math right for your adding and subtracting, your offsets, basically. But the nice thing about this is, all right, so it can draw the TIE fighter, but if I want that TIE fighter to go up higher, I just have to change that. I could make it go up. And there we go. draws in a new location. Or if I want it to shift over to the right, I can say 350 and have the TIE fighter more over to the right. So this is a good thing that you could do, and you could even take this a step further, and you could actually have x and y be your parameter variables instead of down there. And then down here, I could say, put it at 150, 350. And then, or I guess I should do x first. So 350, 150. And then you could have it go that way. So we could go either direction. For the time being, let's leave the x and the y in the function. Just keep that in mind. Now, having it designed that way is going to help for the next problem, which is write the code so that the TIE fighter follows the mouse. So it's kind of like a slightly more complicated version of the program where you just had the rectangle following the mouse. So we want the TIE fighter to, when the mouse stops, to be at the center of the TIE fighter. So how do we do that? Well, given the updated version of the code, this is actually going to be really easy. Because the only thing that we have to do is we have to change our x and y to be the mouse x and the mouse y. So let's say GUI.mouse x, GUI.mouse y, and as long as I've done all this math right, it should be able to just work. So look at that. The TIE fighter follows the mouse around on the canvas, and that is awesome. So it's important sometimes to think about how you're designing things, or if you have designed something wrong, sometimes refactoring can be a good thing, right? Once you realize, oh, I should actually not hard code these values, I should make them all relative to an x and y variable, you can do that, because it would kind of stink if you had to put mouse x and mouse y throughout those lines when you're doing your calculations. Rather, create an x and y variable, or some kind of variables, and then you can have your shapes be drawn relative to those. All right, so another step that we need to accomplish is this. So notice what's going on there. Take a close look at the canvas. So when the mouse moves, the TIE fighter also moves, but it's kind of like the TIE fighter moves more slowly than the mouse does, right? So if the mouse goes up near the top of the screen, the TIE fighter doesn't go all the way to the top. So this is something we want to do where, okay, so it has to somehow correspond to what the mouse is doing, but not at a 1-to-1 ratio. So what could we change about that function that we just wrote to get it to behave more like this, rather than following exactly where the mouse goes? Let's try to figure this out. So what we could do is, let's think about this. So if I, over in this example, if the mouse moves, let me try and pause it at a good time. Let's go back to where it's going up so I can draw. There. Oh, but the mouse disappeared. Oh, that's a bad time too. Let's see if I can get this. Wow, that's a bad time also. Let's give it one more shot. All right, well, the mouse disappeared. But let's pretend the mouse is at that point. And notice, so the center of the canvas is, let's say, right around there or so. And so what we want to happen is, if the mouse is way up at the top, the TIE fighter should only go up about that much. So we could basically take the mouse's position and divide it by a certain amount to try and get the TIE fighter to move less. So what if, over in this, I just divided by, say, 3. Now if I run that, as I move the mouse, the TIE fighter does move not as much as the mouse due to the division. The problem is it's not lined up on the center of the screen, right, if the mouse is over the TIE fighter. So what I want is when the mouse is over the TIE fighter to be centered. The way it is now is if I put the mouse over the TIE fighter, it's basically up in the corner where the origin 0, 0 is. And if I go down to this point, even then, it's not quite fully centered onto the screen. So what perhaps I could do is I could just offset the TIE fighter, basically add some coordinates to get it so that it's more centered. So let's go and just add, say, 200 to each of these coordinates. and it's not quite there. So when I have the mouse approximately in the center of the canvas, the TIE Fighter is still a little bit shifted down and over too much, over that way. So let's go a little bit less. Let's say 170 and 170. So 170 is not perfect. Well, I don't know. It's pretty close, right? It may not be perfect, but it's pretty close. The actual I have in the slides, I have a different number. So I don't know, that one, maybe I did the math and that's closer, or maybe that was just a guesstimate, who knows. But the point is, let's just worry about getting close, right? We could probably actually do the math out though, because basically what it should be is the math would be whatever the coordinate is at this point, right? So when the mouse is centered, that would be the mouse at 250, 250. But then we'd have to divide that by 3 to get kind of the amount that just this part would calculate out to at the center. And then whatever that is short, we would have to add the remaining amount, right? But let's not worry about actually doing that calculation right now. So 170 is not perfect, it's pretty close. So yeah, so we have very closely gotten to the point of what we saw on the slides. And so this is something that you should keep in mind for the motion parallax assignment. So when it comes time to do that, and when you want to have a program that has the mouse coordinates that move around, and when you move the mouse, the landscape should actually kind of have that parallaxing effect, you're going to want to do something along the lines of this. You're going to want to basically this formula right here, you can reuse that, but you can change, for example, the 3's, you could change that to a bigger number if you want the objects to shift more slowly. And you can change your shift value if you want shapes not necessarily positioned at the same position as the TIE Fighter, but if you want it positioned more over to the left or right or up or down. But basically keep that formula and this kind of pattern of writing code and drawing shapes in mind if you go to work on that assignment. So anyway, I'm going to wrap the video up here. I hope you all enjoyed and have a good one.